All right, so in this video, we'll be looking at how to solve trigonometric equations by factoring. So let's start with this specific example. Here we have to solve for theta between 0 and 2 pi. So if you look at this, we can rewrite this equation as 2 cosine squared theta plus what? 3 cosine theta plus 1 equals to 0, right? Now everything is in terms of cosine, so it's fine. We can factorize this easily. One way we can factorize directly, or we can just make a substitution that u is equals to cos theta. So that now this becomes an equation in u. And this we can factorize easily as u plus 2 and u plus 1. Right. Oh, no, it's going to be u. Yeah, because here we have a 2, so don't forget, if you let u to be this, here it's going to be 2u squared first. Yes, 2u squared. So this now you can factorize this as 2u plus 1, right? Okay. So, and here, what does that mean? It means that here we are saying that u plus 1 equals to 0, or what's u? It's equals to minus 1. So this is equals to 0. Or we can just directly, since both is equals to 0, we can see that 2u has to be minus 1, or u has to be minus 1. And this means that u, it's equals to minus half, or u, it's equals to minus 1. All right, now, from this other parts, what can we see? We can see that if you bring back u, we have that cosine theta is minus half, or cosine theta is just minus 1. All right, so let's deal with the situation where we have just minus 1 here. Now, to solve this, what can we do? Now, this one is a quadrantal. Quadrantal means it's just, we can call it a quadrantals, right? Because minus 1, where is minus 1? If you look at minus 1, if you remember this, minus 1 is going to be somewhere here. You're looking for where cosine is what? Is minus 1. And so this point is what? Is minus 1 and 0, right? Don't forget, this one is what? Is 1, 0. And this is 0, 1. And this is what? Minus 1. I think 0 and minus 1, right? Okay. So here you can see that this is only coming when theta. This can only happen here when theta is equals to what? Is equals to pi, right? If your theta is equals to pi, then this is going to be true. We will definitely get minus. So here we have pi, but we can also add what to k pi or to n pi. This is always true. Now, we finished for the first case. Now, the second case now is this one. This is where we have what we have to consider, because this also we have to consider two cases, whether you are in the second quadrant or we are in the what? In the third quadrant. So let me use a red pen. But firstly, you need to get your reference. So reference θ1 is just an angle in the first quadrant whose cosine is half. And that is nothing but pi over what? Pi over 3, because pi over 3 is 60, cosine 60 is half. But now if we are in the second quadrant, So how do we get our theta in standard form? Because that is what we are interested in. We are not interested in the reference, right? So in this case, our theta is going to be what? Pi minus pi over 3, which is nothing but 2 pi over 3. But then we can add 2k pi, right? And then if we're in the third quadrant, because cosine is also negative in the third quadrant, our theta is going to be pi plus pi over 3. And this is going to be 4 pi over 3 plus 2k pi. All right, so all of these are solutions. This is the first one coming from this, and then we have this one. Okay, but now since we have a range from 0 to 2 pi, so we have to use that range. Our restriction is from 0 to 2 pi. So what can we do? We just substitute, and they are all. We start with k is equals to 0. If k is equals to 0, we go here. We will get only pi. If we come here, we will get 2 pi over 3. And then we will get 4 pi over what? Over 3. So can we let k to be 2? No, k cannot be 1, because if k is equals to 1, it's just going to be out of what we need, because we need the maximum to be 2 pi. So we're done. So our solution is just only 3. Solution set is pi, 2 pi over 3, and then 4 pi over 3. All right, so let's see the next one. So the next question is 4 sine squared minus 4 sine theta. So here also we do similar thing here. We can do our substitution directly because everything is already in terms of sine. So this will become 4u squared minus 4u minus 3 is equals to 0. So here we see how we can factorize this. This times this is going to be minus 12. And this is what? This is minus 4, right? So we're thinking of 2 factors that can give us minus 12 and give us minus when we multiply. So we can go with minus 6 and plus 2, right? Because minus 6 times 2 will give us minus 12. Minus 6 plus 2 will give us minus 4. And then we can also divide by the coefficient of 8u squared, which is 4. And this is going to be 1 over 2. This is going to be minus 3 over 2, right? So this, we can write it depending on which method you use. You can have this as 2u minus 3 into what? 2u plus a 1. And this is going to be equals to 0. And so what does that mean now? It simply means that we will have that 2u minus 3, or 2u is equals to 3, or 2u is equals to minus 1. And this means that u is equals to 3 over 2, or u is equals to minus half. But what is u? U is sine theta. So we have sine theta is 3 over 2, or sine theta is minus half. Now, this clearly is going to be reject. And why are we rejecting it? Since the range of sine is what? Minus 1 to 1. This is the range of sine theta. So sine theta cannot be cannot be greater than 1. All right, so we reject this one. So we have only this case to deal with. Now for this one, sign can be negative in the third and in the fourth quadrant. Right. But firstly, we need to find the reference. So the reference θ1 is going to be an angle in the first quadrant whose sine is half. And that should be sine 30, which we can write as pi over 6. Right. But now we have to consider the quadrants. So if we are in the third quadrant, our theta in standard form is going to be what? Pi plus our reference, which is pi over 6. And this is nothing but 7 pi over 6. And we can add 2k pi. And then if we're in the fourth quadrant, theta is going to be 2 pi minus pi over 6. Right, this is nothing but 11 pi over 6 plus what? 2k pi. Okay. So what can we say now? We just need to find the range. If you look at the range carefully, we have what? We have from minus pi to 2 pi. Okay, now if you look at the domain, we have from minus pi to 2 pi. So it means we can consider some negative k's as well. So definitely we can start, we can try it from, let's say, k is equals to minus 2. This is just trying. If you try from k is equals to minus 2, from this third quadrant, you will have 7 pi over 6 minus 4 pi, right? Because k is minus 2. But now this will be what? This will be, you can multiply this by 6, so this will be minus 24 pi over 6. And this will give us like minus 17 over 6 pi. But if you look at minus 17 over 6 pi, it's about minus, almost minus 2 point something, almost minus 3, which will definitely be outside, because when we are given this one, minus pi, this is the range we have. The range we have is minus pi to 2 pi, right? So just consider on a number line. The coefficient of pi here is minus 1. The coefficient of pi here is 2, right? So if you look at this one, this is, if you have minus 17 over 6, definitely is going to be outside here. So you don't have to include it, right? So it means it will not work, and definitely it won't work also in this case in the fourth quadrant. But let's try k is equals to minus 1. If k is minus 1, what do we get? If you look here, you will get, let's do it here again. If k is minus 1, you'll get 7 pi over 6. It's going to be minus 2 pi, right? Because k is minus 1. And this is going to be just 7 pi over 6 minus what? Minus 12 pi over 6. So you have minus 5 pi over 6. So let's write it down first. We'll check. Now, that is coming from the first quadrant. Then, if you, not what if, I mean from the third quadrant. Then if you go to the fourth quadrant, here, what do you have? You will have 11 pi over 6 minus 12 pi over 6. So this is just going to be minus pi over 6. So this is when we substitute k equals to minus 1. So now let's try k is equals to 0. If you substitute k is equals to 0, we will have 7 pi over 6 and what? 11 pi over 6. Now, can we take k to be 1? No. If you take k to be 1, it's going to be outside the domain given. Now, you see we have how many negative values, minus 5 pi over 6 and minus pi over 6. And if you look carefully, I think both of them are inside this range, because this one, you have to just look at the coefficient, just like I said, and compare the coefficient. This one is minus 5 pi over 6. So you look at this one. This is what you need to look at. So minus 5 over 6 is going to be between 1 and 2. And this is going to be minus 1 over 6. It's also going to be in this. So I think these are the only two negative we can get there. So it simply means our solution is just going to have these two negative values and two positive angles. Okay. So let's see next example. All right. So let's look at this one. How can we solve this? Here you can see we have sine on the left-hand side and also sine on the right-hand side. So we can try to put things together. This is sine theta tan theta minus root 3 sine theta is going to be equals to 0. So we can take sine theta as a subject, as a common factor. Right. So this means that sine theta equals to 0, or tan theta minus this is equals to 0. This one, let's solve this one. Sine theta equals to 0. It means that theta is what is equals to n pi. Yeah, we know this one. And here, n pi, which is the same, but since everything is in degree, so instead of n pi, what do we use? We use 180 degree n. And this is tan theta is going to be root of 3. This is possible in the first or in the third quadrant. So, but first of all, reference theta 1 is what? Is pi over 3, right? That is tan 60. Yes. So let's use it in degree. So 60 degree. But if we are in the first quadrant, yes, it means that our theta in standard form is also going to be 60 degree. Then we can add 360 degree n, yes? Okay. Now we're using 360, not 2 pi, because our range or our restriction is in terms of degree. Then now we go to in the third quadrant. So if you are in the third quadrant, theta in standard is going to be 180 plus 60, which is the reference. And then we can add 360, which is equals to what? And this is going to be 240. Then we can add 360 degree K, right? So here, instead of 40, we can use 180 K, degree K. Right. So let's see. So these are the solutions. But now we can try the values. If K is equals to 0, what do we get? If K is equals to 0, from here, we will get 0 degree, right? Coming from here. When we come here, we'll get 60 degree. And also we'll get 240 degrees. So these are the solutions when you have K is equals to 0. So we are substituting in two parts. This is the first part, and also this is the second part. Now, can we try K is equals to 1? Yes, if K is equals to 1, from this part, we will get what? 180. If we come here, it's going to be more than, because if you put K is equals to 1, already This is 360. Also, this is 360. So it will exceed. So we have only 4 solutions. Our solution set consists of 0 degree, 60 degree, 180 degree, and 240 degree. Okay, so yeah, thanks for watching. So do comments if you have any questions, and likes. Also, don't forget to subscribe to my channel. Thank you for watching. So in the next video, we'll look at some few old exam questions.